So I am a scientist with at the Pacific Biological Station in Irvine, and Sandy, I'm going to try not to wear my shoes. I've even been known to look people in the eye, but not always. We'll see if we can figure out how to work this. So, how do we go forward? Right, so one of the hats I wear is the Canadian lead on International Year of the Salmon. And so Don asked me to come and speak on that. And I thought, well, I can do that. But, you know, most of my research is in the marine environment. And I thought, given that two previous speakers are focusing on freshwater, that I would say just a few things about sockeye survival and growth in the ocean, and how that might be affected by pink salmon and the relationship with or implications to enhancement. So first of all, what is International Year of the Salmon? I think most people here haven't heard of this. And it's, well, first of all, what it isn't a year. It's kind of like International Polar Year. It wasn't a year. It kind of went on for a decade or so. An International Year of the Salmon is kind of a similar sort of concept, that it goes on for multiple years. And it's, if there is a year, it's probably 2019. But it's considered to be an intensive burst of internationally coordinated, interdisciplinary scientific research and outreach. But the thing is, it's focused on Pacific and Atlantic salmon, and not only the fish, but their relationship to people. So it's kind of a big deal. So right now we're in the planning phase. We have had a number of national and international meetings. We're just kind of getting our act together, I guess, identifying research priorities and core partners. Sometime probably late in 2018, there'll be an international symposium which will launch this. We're hoping to have sort of simultaneous coordinated field activities throughout both freshwater and marine, but we're envisioning sort of simultaneous sampling in the North Pacific by multiple countries, trying to look at critical periods and critical times within the ocean with respect to salmon. So that will happen 2018, 2019, and then there'll be a period of sort of research to you know, write out the results, that kind of thing. So the thing is, this really is a hemispheric initiative for the Northern Hemisphere. And in fact, we've even invented a new word, which is Salmosphere. And this is Skip McKinnell that kind of came up with this word. He's quite clever with this sort of thing. And so the Salmosphere is the current and future distribution of salmon, both Pacific and Atlantic, in the Northern Hemisphere. So when you think of the area that encompasses, and I will try to figure out the laser pointer here. Basically, it includes you know, much of the north half of the North Pacific, and also the north half of the Atlantic oceans, and we're trying to include also the Arctic, because we're seeing many more salmon straying to, but also returning to and spawning within both the Canadian and the American Arctic, and the Russian as well. So why are we doing this? Well, for those of us in southern BC and south of the border, you know, we sort of have this perception that there's many of our stocks that are declining. And that's true in that part of the world, but I'll show a slide in a moment that shows that in the North Pacific, actually salmon as a genus are actually doing very well. But what's happening is increased variability, and Dan talked a little bit about this. And so those of us that work on Fraser sockeye, in the last 15 years, we've had two of the lowest returns in over a century, and two of the highest returns in over a century. And you know, this kind of variability is really hard to manage for. And so we're just not able to respond quickly enough. At the same time, there's some incredible methodologies and new techniques that that are being developed that I think will allow us to respond more quickly to this kind of variability. You know, one example would be just the miniaturization of tags. So you think of the tagging techniques that, you know, where people used to apply tags to tuna and sharks, and you get these pop-off tags that go release and transmit their data to the satellites, and archival tags. And anyway, a lot of these tags are getting smaller and smaller. So we can now start to tag salmon and have a much better understanding of where they go in the ocean, both vertically and horizontally. Genetics and genomics, and there's so many new technologies that are becoming available. Now, the International Year of Salmon won't be funded by sort of traditional government funds. There just isn't that kind of money available, but there's all sorts of other organizations that, particularly when you link salmon to people, there are additional funds available. The other reason we're really trying to get into this is succession planning. You know, we really need to get younger people involved and excited about salmon. You know, that we don't want everybody going into medicine and engineering. So, in terms of the partnerships, you know, Government of Canada is involved, but really it's the North Pacific and Adams Fish Commission and the sister organization in the Atlantic, NASCO, that are primarily responsible for implementing this program. We've made contacts with many other organizations, but we have a long ways to go there. I don't have time to kind of go through the different themes in any detail, but you can read it on the slide. So there's 6 main themes, and these are the outcomes that we hope will result with respect to these themes through International Year of the Salmon. But it's, you know, it's about improving our understanding of the status of different populations, understanding better how salmon will respond to a changing ecosystem. New frontiers is just the new techniques and approaches that are developing. IYS will not be successful unless we do a better job of linking salmon to salmon-dependent communities, indigenous peoples, information systems, and a lot of us are just, you know, we're still using, you know, we use Excel files or whatever to keep track of our data. A lot of the information systems are just so far beyond that. I mean, they have to be able to link to those types of data, but there's many other types of information that can be now assessed and made available to the public and to others working on salmon. And outreach and communication is really important. So just to summarize, IYS is in the planning phase. We're just starting fundraising. And the other comment I want to make is that the major themes are linked not only to biological science, natural science, but also social science. So this is you know, something I find really interesting, and this slide is courtesy of Greg Ruggieri, who's been responsible for some of the slides I've got in this presentation, and he and I are working quite closely on this. And it's kind of what happens in the ocean. So is there evidence that our sockeye in both Canada and the United States, are they being impacted by other salmon? And I'm going to focus here on pink salmon. Wish I could turn this thing the right way. So this is a summary graph that Greg and I put together last year, and it provides estimates of adult salmon abundance in the North Pacific from 1950 through to 2015. And the bottom histogram, or portion of the histogram that's supposed to be pink, is pink salmon. The center one that's blue is chum salmon, and the red, the top portion of each bar are sockeye salmon. And there's 2 points I want to make. The first is that we are near record abundances of salmon in the North Pacific, and it's driven by pink salmon and chum salmon. Pink salmon numerically, and chum salmon by biomass because they're heavier and they're in the ocean longer. So it's not as if all the salmon populations are crashing. It really depends on the species. So we have these kind of data for all the different areas of the ocean. The other point I want to make is that there's a really interesting variability between the number and the biomass of salmon in the ocean in odd years compared to even years. And the reason is pink salmon. We've got different areas of the ocean where odd year returning fish are dominant, other areas where even year fish are dominant. But on the whole, odd year pink salmon are more numerous than even year pink salmon. And pink salmon in even and odd years, they're genetically isolated. They probably should be different species. And for various reasons, odd year returning pink salmon seem to be doing better under the current climate regime. So anyway, what's interesting is you have a natural experiment. So you have during odd numbered years, pink salmon are more abundant than in even years. And so if pink salmon are having an effect on sockeye, you'd expect to see differences in even years and odd years. So hold that thought, we'll come back to it. So this shows the marine distribution of three species in the North Pacific. The top panel is pink salmon, the center panel is chum salmon, and the lower panel are sockeye salmon. The yellow diamonds, or I guess they're triangles, those are fish from North America. The red diamonds are fish from Asia. And I just want to point out the lower panel, the yellow triangles, those are the sockeye from North America, both Canada and United States. And they're in the Gulf of Alaska, as you'd expect, and also the Bering Sea. But what's interesting is how far west they go. They're a long ways out there in the ocean. And when you align the distribution of those yellow triangles in the lower panel with the yellow triangles and red diamonds, so let's say in the top panel, which is the pink salmon, obviously North American sockeye overlap with North American pink salmon, that's no surprise, but they also overlap significantly with Asian pink salmon, and Kamchatka is actually probably the largest producer of pink salmon out there. Okay, so I've got a couple of complicated figures from Greg's work, and the first one here is Bristol Bay, because I figured there's quite a few people from Alaska. The next slide shows some results with salmon to the south, largely Fraser River sockeye. And so what this shows is each of these graphs, there's a 0 point, and the years when salmon are growing faster than normal are above the line, and the years that salmon are growing slower than average, they're below the line. And to show the difference between even and odd years, we've colored in the odd year bars and left the even year bars empty. The left-hand panel of figures is sockeye salmon growth in their second marine year, and the right-hand panel is sockeye growth in the third marine year. And there are 5 different stocks from Bristol Bay. And so what you see is that the dark bars are predominantly below that 0 line. So what that's telling you is that sockeye salmon from Bristol Bay are generally growing much faster during their even years in the ocean than in their odd years. And so this is consistent with the idea that these fish are competing for food with pink salmon, which are more abundant in the odd years. So this next figure, a little bit different, but it shows a number of stocks along the horizontal axis. Weaver Creek that Dan was talking about is the one on the far right. And there's, it includes most of the Fraser River populations, a bunch of Kaskinanas, and a few from Alaska. Now the upper left-hand panel shows survival, and the idea is, are even-year broods doing better than odd-year broods? And again, the bars below the horizontal line are the years that are doing poorly, and the bars above the line are years in which they're doing well. And what you see again is that the odd-year brood line is doing less well in terms of survival than the even-year brood line. The two lower panels, the one on the left is the size of returning male fish, and the right one is the size of returning female fish. And I won't go into detail, but once again, the male and female sockeye for most of these stocks that return in an odd year when they compete with pink salmon in the ocean are growing slower. So I'll just wrap up here, and basically, in summary, salmon abundance in the North Pacific, the numbers in biomass are near all-time high levels, largely due to favorable marine conditions, but also the release of large numbers of pink and chum salmon, primarily from Alaska, Hokkaido, and Russia. And there's this really interesting even odd-year difference, with odd-year salmon being much more numerous than even-year salmon because of pink salmon. North American sockeye overlap in distribution with pink salmon from North America and Asia and consume similar prey. I think I forgot to mention that, but the overlap in feeding between pink and sockeye is fairly significant. And so what we've found is that there's reductions in growth and survival for sockeye in odd-numbered years, and this is consistent with the hypothesis that competition from pink salmon results in reduced growth and survival for sockeye. So to me, the kind of take-home message here is that we should be concerned about potential impacts of increasing numbers of pink salmon in the ocean, because this will, I'm quite sure, have significant detrimental effects on sockeye salmon, particularly if the carrying capacity of the North Pacific is reduced, which is what is projected under most of the climate models. So, if I can figure this out, I'll just put up the references that where most of the data are provided, and thank you very much.